So in this video today, we're going to talk about how to calculate and interpret z-scores. So let me get my little thing here so I can move over. A z-score is used to create a standardized normal curve. So the standardized curve always has a mean of 0. So if you look down here at our curve, we have our mean right here of 0. And the standard deviation of 1. So a z-score for a value is the number of standard deviations that the value falls above or below. So basically, if we start looking at this curve, then this is 1 above, that's 2 above, that's 3 above, right there. And then we got our 1 and our 2 and our 3 out here, right? So these would be our normal percentages in here, but we're going to actually use the calculator to find these, okay? So again, the number of standard deviations that fall above or below the mean is what we're doing. So that's why these ones on the left are negative and the ones on the right are positive. Z-scores give us a way to compare two different variables from different data sets to one another based on where they are located in relation to their individual means. So the formula for the z-score is z is equal to a value, that's what this x is, minus the mean, remember mu means mean, divided by the standard deviation. So this is actually the formula that we use for finding the z-scores for population, okay? And this is on your formula sheet. So a z-score with a positive value is above the mean, and a negative z-score means it's below the mean, and a z-score of 0 means it's actually equal to the mean. So now we're going to actually use this information to do a problem. Brianna is competing for a promotion at work with 100 other people and took her practice exam. The practice and real exam were based on 3 categories: leadership, quickly processing information, and data analysis. So the good thing is that Brianna was above all 3 categories, the mean in all 3 categories. So notice she got 22 here, there's the mean, 18, 12, mean was 9, 34, the mean was 32, right? So she has 3 weeks to study for her real exam and wants to put more of her study time into her weakest category. So to find this out, she's going to calculate her z-scores. Okay, so now if you recall, up there above, we had that we take our value, whatever that is, that's going to be these over here, and we're going to subtract our mu from them. That's what this is. And then we're going to divide that by our standard deviations, okay? So we're going to find this for each of the values below. So for leadership, we're going to take this is our x right here, okay? We're going to take x and we're going to subtract from it this, the 18. Sorry, I didn't mean to put x there. I meant to put 22. So we're going to put 22 minus the 18, and we're going to divide that by our 4.8. So just recall that we got to do what's on top first, okay? And then divide by 4.8. So we get 0.83 here, right? I don't know why the other dot appeared there, but y'all get it. All right, so our next one, same thing for z-score for processing information. So once again, we're going to take our x here, right there. We're going to do 12 minus the mean, and then we're going to divide that by our standard deviation. Recalling again that if you're going to put it in the calculator, you've got to put it in here like this, okay? So we did this one, it was 2.5. Our last one is our 34. So we're doing 34 again, minus our 32. And then we're going to divide that by our standard deviation. That's our 1.8, okay? So that's going to give us 1.11. So now, when we're trying to make a decision about how she wants to invest her time, obviously her weakest was leadership, right? And her strongest was processing information. So we can actually rank these right here, right? So we do 0.083. That's like right about there, right? 0.83. Okay, and that was leadership. Then we have our 2.5, which would be right over here. So 2.5 was what? Processing information. And then in the middle, we had our score for data analysis. So that's like at 1.11. So that's data analysis. So if we were to look at this, moving from left to right, we could tell which one she needs to spend the most time on. So it looks to me like she needs to spend the most time on leadership, and then data analysis, and then processing information. Processing information was much higher than all the rest, okay? So if she's going to make a decision about how she's going to study, she needs to spend time first on what? What was her weakest? Leadership. And then do the next, which would have been data analysis, or data analysis. And then if she still has time, she should work on processing information because that was her strongest, okay? Processing information was her strongest. Could be great if I could spell, right? And if my pen would quit running, stop working on me. It's not being happy with me today, y'all. Okay? So that's the order in which she should study. So the next one says you try 1. The mean speed of vehicles along a stretch of highway is 56 miles per hour with a standard deviation of 4 miles per hour. You measure the speed. So this is going to be our mu, right? And this is going to be our sigma, okay? So you're going to use the same formula that we used before. Go ahead and do this one and then come back to me when you're done. So we're going to do 62 minus 56 divided by 4 here. And again, when we do that, we get 1.5. And remember, our mean is 0. So 1.5 means what? This is above the mean, okay? Because it's asking us also to, of course, to interpret the z-score. So this one's above. I just cannot write today, y'all. I don't know what is going on with me. So this one is above the mean, okay? Let's do the next one. So this one is going to be 47 minus 56 divided by our 4. And this one's going to end up being negative, right? So this is going to be a negative 2.25. So that means this one is below the mean. And then the 56 minus 56 is what, guys? 0, right? We divide 0 by 4, we get 0. So this is the mean, okay? This one is our mean because it's 0. Okay? All right, now let's go on to this next example. So this one says the speeds of vehicles along the stretch of highway have a mean, again, of 56 and a standard deviation of 4 miles per hour, right? So this is similar to the previous problem, only this time we want to talk about how to find the speed that corresponds to each z-score. So we're going to use our same formula, only this time we're going to say our 1.96 is going to be equal to our x minus our 56, right? And then that's going to be divided by 4. So how do we get rid of something in the denominator? We multiply both sides by it, right? So when we multiply, what did I get? Sorry. 4 times 1.96, I get, I'm going to go over here, 7.84, and that's equal to x minus 56. So I'm going to add 56 to both sides, right? So my answer here is 63.84, and that would be miles per hour, right? Okay. And obviously that is above the mean, right? This one's above the mean. And we should have already known that because of our z-score, right? Our z-score is 1.96. So let's go ahead and talk about what b is going to be. So b is going to be below the mean, right? And c is going to be the mean, okay? So we should be able to look at that immediately and be able to assess that piece of information, okay? So, and if you notice, this person up here is going almost 2 standard deviations above the mean, right? So that would be, if I added 8 to this, which would be 2 standard deviations. So this is actually 2 standard deviations above the mean. Okay, now let's do this next one again. Same thing, all right? So we're going to go negative 2.33 and set that equal to our x minus our 56 again, divided by 4. So this time we're going to multiply 4 times negative 2.33, right? Because we're going to get rid of that 4 again in the denominator, right? Multiplying 4 times both sides. So that's going to get us negative 9.32, and that's going to be equal to, again, our x minus 56. So we're going to add 56 to both sides again. So we're going to add the 56 here, and we're going to add the 56 here. So really we're going to subtract 9.32 from the 56. So that means our value for x here is going to be x is equal to 46.68. And this time we're about 2 1/3, a little more than 2. We could say a little more than 2 standard deviations, right? Below the mean. Okay, so this time we're below the mean. And that's a little more than 2 standard deviations below the mean. Okay. All right, so 0. So you should know, if we have 0 here, we got 0 equals x minus 56 divided by 4, right? Multiply 4 times both sides again. Hopefully y'all already know that this is going to be 56, right? So when we do that, that's gone from there. So we have 0 equals x minus 56. Add 56 to both sides, so 56 is equal to x. So this is the person's traveling at the mean, right? So traveling at the mean. Okay? All right, so let's see if you guys can do this. You try and then come back to me when you're done. So this one, again, says a representative sample of trees in a forest shows the trees to have a mean circumference of 19.7 inches and a standard deviation of 13. Okay. Assuming the circumferences are normally distributed, what is the z-score for a tree with a circumference of 22? So we're going to take our 22, we're going to subtract from it the 19.7, and then we're going to divide all of that by our 1.3. And we do that, we get 1.77. So the answer was C. All right, now, what we're going to do now is we're going to actually use the z-scores to find probabilities, okay? So it says a 100-watt light bulb has an average brightness of 1640 lumens with a standard deviation of 62 lumens. So what is the probability that a 100-watt light bulb will have a brightness less than 1550 lumens? Okay. So we're going to use our formula to find the z-score. So x minus mu divided by sigma, right? So that's going to be equal to, our x is going to be our 1550. We're going to subtract from it our 1640, because that's what it said the average was right up here, right? So that's our mu, and that's our sigma, and then we're going to divide all of that by our 62. So when I do that, I got negative, because that's going to be a negative number up on top, right? So negative 1.45. So we know it's going to be below the mean, right? So our probability is going to be is that x is less than 1550, right? So our z-score is going to be less than what? Our negative 1.45. Negative 1.45. So I probably should move that over a little bit. Okay, so when we calculate this, we can calculate this in the calculator. Now, here's the key, okay? When we're doing this with the z-score, our mean is always going to be 0, and our standard deviation is always going to be 1. So what we need to figure out now is, again, if we look at our curve, and we're at negative 1.45, so that's over here, right? And it says less than, right? Suppressed brightness less than, see less than right there? Okay, so we're going this direction. Okay, so do we have, is the negative 1.545 an upper bound or a lower bound? It's going to be it's going to be an upper bound, right? So we're going to go negative 1.45. Our lower bound is going to be our negative 1 million again, okay? So I'm going to show you guys how to do this on the calculator. So we're going to go, I'm going to clear this out, and we're going to go to second vars, which is distribution, D-I-S-T-R, see that? We're going to go down to number 2, as we have been, and we're going to actually just put in our lower bound, which was negative 1 million. And then we're going to put in our upper bound, which we said was negative 1.45. Now remember, when you're using z-scores for this, okay, you're always going to do this to 2 decimal places. And then when we find our mu is always going to be 0, and our standard deviation is always going to be 1, okay? So we're going to click enter here and click enter again. So notice what I got. I got that this is 0.07353, okay? 0.07353. And we're going to do this to 5 decimal places, okay? So our answer for the probability was equal to 0.07353. And again, if we had to write that as a actual percentage, it would be 7.353%, okay? All right, let's go on to the next one. So this one's B, and it says, what is the probability that a 100-watt light bulb will have a brightness more than 1800? Okay, so here again, we're going to just find our z-score first. So we're going to take our 1800, we're going to subtract from it our 1640. I can already tell this one's going to be a positive one, right? And we're going to divide that by our 62. So our z-score this time is going to be 2.58, okay? Now, key here, okay, is it says more than 1,000 lumens, okay? So when we think through this problem, we're going to go like this, right? So we got a 2.58 over here, 2.58, right? And we're going this direction, okay? So again, we're going to talk lower bound, upper bound, okay? Because that's going to be key to us finding the answer to this problem. So we want the probability that X is greater than, right? Or what? So our value here is greater than our 1800, right? So 1800 here, sorry. And then our z-score is going to be greater than 2.58, right? Okay, so here again, we know that our lower bound is going to be 2.58. Our upper bound this time is going to be 1,000,000. So our mean is still 0 and our standard deviation is 1, okay? So we're going to go back to our calculator and see what we get. So here again, we're choosing distribution, which is second bars. Going to go down to number 2 and enter. This time we have a lower bound of, we said 2.58, right? 2.58. Upper bound this time is going to be 1,000,000. So we're going to put 1,000,000 here. 1, 2, 3, 4, 5, 6. Mu is 0 and standard deviation is still 1. We're going to click enter, enter, enter till we get our value. So this one, we got 0.00494, right? So that's what we're going to put in there. So our probability here is 0.00494. And remember, if we were to do this one, it would actually be 0.4%, okay? Because we're going to move the decimal place 2 places to the right if it asks us actually to put it as a percentage. All right, let's look at our last one here. This one says, what is the probability the 100-watt light bulb will have a brightness between 1600 and 1700 lumens? So this time we're going to have to find two z-scores, right? So we're going to do our 1600 minus our 1640 and divide that by our 62. So once again, when I do that, I got 0.65. And then we're going to find our other z-score. So we're going to find the 1700. So we're going to do 1700 minus, oh, by the way, that's a negative, right? Yep, negative 0.65. Okay, and so then 1700 again minus our 1640, again divided by our 62. So that one was 0.97. So that means we're looking for a value between 1600 here, right? And 1700, right? And then we're looking for our z is going to be between negative 0.65 and what? 0.97, okay? So this time you should be able to tell we have a lower bound and an upper bound, right? So our lower bound is going to be that negative 0.65. Our upper bound is going to be the 0.97. Our mean is still 0 and our standard deviation is 1. So we're going to go into the calculator now and enter that. Go into distribution again. So our second vars going down to number 2. And here we have a lower bound and an upper bound. So we're going to do our negative 0.65 is our lower bound. Always smaller numbers are always going to be your lower bound, okay, guys? And then you got 0.97 here is our upper bound. And again, we still have our mean as 0 and our standard deviation is 1, okay? So enter that, and we got this time 0.57613, okay? So this one's equal to 0.57613, which again would be 57.613%, okay? All right, we got a couple more to do. So on our You Try 3, it says tests show that a certain model of new car average 36 miles per gallon on a highway and a standard deviation of 3 miles per gallon. Assuming that the distribution is normal, find the probability to the nearest 10,000ths of a car of this model gets the indicated mileage, okay? So we can do this with z-score or we can do it regular. So I'm going to show you all how to do it with z-scores, okay, just for the practice. So again, we've got 40 minus our 36 divided by the 3, okay? So that's going to be, what is that? 4/3, which is 1.33, okay? So again, if we put this in, it says more than 40 miles per hour. So that means we got a 40 here, right? And we're going that direction. Okay, so that's our 1.33, but it's more than. So that's our lower bound. This is going to be our lower bound. Our upper bound is going to be 1,000,000, right? So you put lower bound is this, and our upper bound is 1,000,000. And when we do that, we get, for our answer, 0.0918. Right? Hang on, let me double check. I think we need 5 decimals. So y'all see this 59 right here? Obviously that would round up to a 60, okay? So this should be a 6, 0.09176, okay? So our next one is less than 30 miles per gallon, okay? So here again, we're going to do our 30 minus 36 over 3. So this is obviously going to be -6 divided by 3, which would be a -2. So this time it says less than. So this is going to be our upper bound this time, right? Because we're going left, okay? So we're going to then go back in here and we're going to put this in the calculator. So second vars and down to 2 and enter. So we're going to do our lower bound at -1,000,000, our upper bound at -2. Our mean and standard deviation stay the same, 0 and 1. And so we're going to push enter there. So this is 0.00275, okay? So I went ahead and wrote that right there. Okay, so now we're going to do the next one. It says between 34 and 38 miles per gallon, okay? So this time we're going to do our 34 minus our 36 divided by 3. So that's going to give us a -2 divided by 3, which is going to give us -0.67. And then we're going to do our 38 minus our 36, which is also going to give us a 2 again. So this is going to be a positive 2/3. So this is going to be a 0.67. So this would be our lower bound, and the other one would be our upper bound. So we can just enter those again into the calculator. And, excuse me, when we do that, I'll show. So here we are. I'm going to do a -0.67 for the lower bound, and I'm going to do 0.67 as the upper bound. Click enter, 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 enter one more time. So this one is 0.49714. 49714, okay? So this is equal to 0.49714, okay? All right, so I'd like you guys to do this. You try down here and come back to me when you're done. Actually, let me just say this before you start it. You can do this one of 2 ways. You don't have to use the z-scores to solve this problem because you have our mean here, and we've got our standard deviation there, right? And it says 3 years, 10 years, 6 to 8 years, right? So you can do it both ways. You could do it the way that we've been doing it with just the calculated lower bound, upper bound, mean and standard deviation, or you can do it with a z-score. I'm going to do it with a z-score just for extra practice, okay? So you guys go ahead and do your thing. Come back to me when you're done. So on this one, I'm going to do our 3 minus the 6.3 divided by 2.3, okay? So if I do 3 minus 6.3, and then I divide that by 2.3, I get -1.43, okay? So now the question is this going to be an upper bound or a lower bound? So this says a homeowner will sell or move within 3 years of buying the house. So if I've got my 6.3 right here and my 3 here, it says within. So we're going that direction, right? So that means that this 3, or this number right here, is going to be an upper bound, right? So our lower bound would be -1,000,000. So go ahead and put that in the calculator and come back to me. So we're going to do -1,000,000 here. And then our upper bound was -1.43. So negative 1.43. Our mean and our standard deviation say the same. So this is 0.07636. So now we're going to go back here. Sorry. So what I'd like to show you guys now is if you did this with just the numbers that are there without standardizing it, i.e. without the z-score, okay? So here the lower bound would still be negative 1 million, right? But our upper bound would be the 3, okay? So we're going to put the 3 in here. And remember, our mean was 6.3, so we're going to put our 6.3 here. And then we're going to put our standard deviation, which was 2.3, okay? So we click enter here again. So notice this is a little different, okay? So the standardized is 0.07636, right? But this, if we put in the values, it's a little bit different. So when you standardize it, it is going to change the value just a little bit, okay? So that's important. So this is equal to 76. Oh, jeez, I can't remember anything today, y'all. So let me go back to my calculator here. 0.076356. No, 7636. Yeah, there we go. 0.07. That's what I did. Put the 0 in the wrong place. Again, 0.07636. Okay. All right. So let's see if you guys can do the last two and come back to me. So the next one is a homeowner will sell or move after 10 years of buying the house. After 10 years, okay? So this time we're going to do, again, our 10 minus our 6.3, divide that by our 2.3. So if you do 10 minus 6.3, that's 3.7, divide that by 2.3, that's going to give us 1.61, okay? So now that's the value that we're going to use. And it says sell or move after 10 years. So that means here, if we got 10 years here, we're going that direction, right? So now this is going to be our lower bound and our upper bound is going to be 1 million. Once again, second, and we're looking for our distribution here, right? Choose number 2, enter. Okay, so this time we had that our lower bound, let's go back there 1 second, was 1.61, right? So let's go back to here. 1.61 was our lower bound, and our upper bound was going to be 1 million, right? So let's put 1 million in here. And then again, remember our mean is 0 if we're using the z-score, and our standard deviation was 1. So we're clicking enter again. So this time we got 0.0569, so that's actually going to be 0.05370, right? Because this 69 is going to turn to a 70. So, all right, let's go back and put. So this one is equal to 0.0537, 0.0537, because that 69 turned into a 70, right? All right, let's extend our page down here and do our last one. Homeowner will sell or move after 6 to 8 years. Okay, so we're going to do our 6 minus our 6.3 again, divided by our 2.3. And we're going to do our 8 minus 6.3 divided by our 2.3. Okay. So respectively here, I got negative 0.13 here, and I got 0.74 there, okay? So again, this would be our lower bound, and the right one would be our upper bound. So enter that into the calculator, and let's see what you get. So for this one, I got that it was 0.32207. Remember, that would be 32.2% if we had to write it as a percentage.